All right, welcome to Exam 1 review. Oh, a little red one. Yeah, perfect. Okay, so remember, your exam is on chapters 1, 2, and 3. If you're in my in-person class, I wasn't sure how much we'd get through. We got through it all. If you're in my hybrid class, you got through it all at home. So, chapters 1 through 3. Before we start, right, just a couple caveats. Not everything from this review is going to be on the exam, and not everything on the exam will be on this review. The best study method, I would say, is to go back and rework old homework problems or quiz problems, online practice problems. It's much better to practice and do a bunch of old practice problems than to just read your textbook over and over again. They call this active recall. It helps with studying. It's just, it's been proven to work better scientifically. So rereading your notes is helpful. And if you don't understand a concept, yes, go back and reread. But what's more helpful is doing those problems. And then study with others. That's always a good method if it helps. Questions before we get started?
I have a question.
Yeah.
I don't think that we got our quizzes back.
Yeah, you guys, I didn't see you in time to give you the quizzes. Yeah. So they're graded. You should have a grading canvas. Yeah. Okay. Yeah. I have it if you want it.
Yeah. Okay.
Yeah.
Okay.
Because I only see you guys once a week.
Yeah.
So, yeah. So you took it last Tuesday. So, yeah. All right. Okay, so the number 5600 expressed in scientific notation with 2 sig figs is what? A, B, C, or D? Try it out. See what you get. All right, what do we think? First step, what is it? C. Let's see. It's actually B. So let's see why. So I actually did this a while ago, so I actually don't remember. So 5600, right? So what you want to do is you want to figure out where that imaginary decimal point is. Where is the imaginary decimal point? At the end, yeah. And then you want to move that decimal point until it's between 5 and 6, and a number between 1 and 10, right? So we're going to go 1 and 2 and 3. The reason we have it right between that 5 and that 6 is so that we get a number out that's between 1 and 10, right? That's the rule. So we have 5.6, and then we moved that decimal point 3 places. So we're going to have times 10 to the something, either -3 or +3. Why is it +3? We're moving the decimal point to the left, and also, right, this is a large number. 5600 is a large number. We're not trying to change this number here, so when you plug in 5600 or 5.6 times 10 to the 3 in your calculator, you should get the same number. If you type in 5.6 times 10 to the -3, you're not going to get the same number, right? What would 5.6 times 10 to the -3 look like? Yeah, 0.0056. Yeah. Different number, small, right? So, not that one. Erase it. Okay, make sense?
Yes.
Now, remember, as a number in scientific notation with anytime you see, whatever number you see here, is how many sig figs you're going to have. So, in this case, right, we have 2 sig figs there. We didn't have to do any changing because it's in scientific notation. So whatever number of sig figs you have before your times 10 to the something is how many sig figs there are. So that's why it's 5.6. Sound good?
Yes.
Make sense? Questions? Okay. All right. How many sig figs is in the number 20400 or 20,400? How many sig figs? Yeah, how come it's 3 and not 5?
Because
Yeah, trailing zeros only count if there's a decimal, right? So this 2 is significant. This 0 is significant because why? Sandwiched, right? And then the 4 is significant. Yeah, so 3 sig figs. 3 sig figs. What if it was 204.00? Then how many sig figs? 5. Yeah, you guys got it. There's no tricking you. Okay. Let's keep moving along here. All right, then we talked about unit conversions in chapter 2. So this says convert 1.4 liters to how many centiliters? Centiliters. All right, what do you guys think? Which one? 140, yeah, D. Yeah, let's see how we got that. So we start with 1.4 liters, right? That's what we're given, okay? So that's what we start with. And then we want to get to centiliters, so that's our goal. Which one's bigger, liters or centiliters? Liters are bigger, right? Centiliters are smaller. How many centiliters are in 1 liter? How many little things in one of my big thing? 100, right? Centi, like century, right? So 100 centiliters equals 1 liter. It could have been meters, right? 100 centimeters equals 1 meter. 100 centigrams equals 1 gram, right? That's your base unit. So that's just a little review there. Okay, so we start with 1.4 liters, and we want to get rid of liters. If we want to get rid of liters, where does liters have to go in that fraction? Top or bottom? Bottom. Why? We have to cross them out, right? So liters over here is going to cancel out with liters down here. Okay. All right, so if 1 liter is on the bottom, right? I'm using this equality. If 1 liter is on the bottom, what goes on the top? 100 centiliters, yeah. The other side of my equality. Now this is great because liters cancel out. And we're left with centiliters. How many centiliters? Well, that comes from calculating it, right? So you got to plug that into your calculator. 1.4 times 100, just 140. You can also think of it as moving the decimal point if that helps you out. So looking here, you can move the decimal point 1 and 2 over. That's just multiplying by 100. 2 decimal places because you have 2 zeros in 100. If that helps, great. If it doesn't, forget about it. All right. Sound good? Keep moving along. All right. One more. Let's try this. 438 milliliters. And now we want to get to liters. What goes on the bottom? Milliliters, because we want to cancel them out. And then liters has to go on top, right? Because we want to get to liters. So are liters bigger or milliliters? Liters are bigger. How many milliliters are in 1 liter? 1,000. Yeah. 1,000. Or 10 to the third. Right? Same thing. All right, so now those milliliters are going to cancel out. And what's our final answer? $438 divided by 1,000, so we can go 1 and 2 and 3 over, and that'll give us 0.438 liters. Let's double check that that's correct. Yay! Ding, 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 ding. How you guys feeling about that? Unit conversions, not too bad? Okay. All right, a penny resting is an example of a physical change, a chemical change, or neither. Chemical change, yeah, rust, right? We had copper, and now we have rust. Well, we know pennies aren't just copper, right? From our pennies lab. But yeah, that's a chemical change. Anything rusting is a chemical change. You start with one thing, and you get a totally new substance at the end. What would be an example of a physical change? Can anyone think of one? Ice melting, yeah, going from solid ice to liquid ice. Perfect example of a physical change, right? You still have water. We call it something different because it's solid water versus liquid water. But still water. All right, a neutral atom must have the same number of what? Protons and neutrons, neutrons and electrons, or protons and electrons? Protons and electrons, C, yes. You gotta have, right, if protons are positively charged, whoops, and electrons are negatively charged, neutrons don't have any charge, right? They're just neutral. So if you have pluses and minuses, you gotta have those canceling out in order to get your atom to be neutral. All right, which of the following is an alkali metal? Some vocab for you here. Alkali metal. And how would you know? How would you know? You can talk to a classmate about it if you want. This one you gotta dig for a little bit, huh? Alkali metal. What group are alkali metals in? 1A. 1A, yeah. So now your job is, okay, I know group 1A is alkali metals since I've memorized it, right? So which one of these elements is in group 1A? Yeah, sodium. Sodium's in group 1A. Right, so remember the first group 1A on the periodic table very left is alkali metals. Second group is what? Alkaline earth metals, yes. And then we have, all the way on the right, we have the noble gases. And then to the left of those in 7A, we have what? Halogens. And that's all she wrote, I think, yeah. And then transition metals are where? In the middle, the short columns, right? Yeah, you guys got it. You're doing great. Okay, let's keep moving along. All right, what element is located in period 2, group 4A on the periodic table? Period 2, group 4A. So this is asking you, do you know what your periods are versus your groups? Yeah, what do you guys think? But this is just like, yeah, makes sense. Carbon? If you said carbon, you would be correct. So sorry to anyone who's listening online, but I gotta move over here. So, right, periods are what? The rows or the columns? Rows. So we're in period 2, second row, group 4A. 1, 2, 3, 4A, right? Not 4B, right? 4A. That one, carbon. Okay, carbon. Good old carbon. Questions? No? Good? Okay. All right, this one I don't have multiple choice for you. You just got to do it on your own. So what is the full electron configuration for sodium? Not sulfur, right? Sodium. Sorry, these are not electrons. It was just a colon. We'll do an equal. equals sign, I guess. Let's do that. All right, anybody want to give me what they got? What they get? What you get? 1s2, what else? 2s2, 2p6, 3s1. Yeah. 1s2, 2s2, 2p6, 3s1. So if you're sodium, right, you're number 11 on the periodic table, and our job is to populate electrons until we get to sodium, right? So sodium's over here. We get through 1s1 where hydrogen is, 1s2, then it jumps down, 2s1, 2s2, beryllium, 2p1, 2p2, 2p3, 2p4, 2p5, 2p6, I feel like we're getting teacher. And then you get all the way to 3s1. Okay. Questions about this? This confuses people every time. Yeah.
So are you basically just counting down and across, and then you're just adding the square how many like places over?
Exactly. Yeah. So look at this. So these here that I'm highlighting, what do these tell you about your electrons in that? What? The energy level of the electrons that are in that shell, right? So those highlighted are the energy levels. What's the highest energy level here? 3. Yeah. What do the S's and P's, what the heck are those? Subshells. What do they tell you about your electrons? How many electrons are in the subshell, right? Also, they're the shape. The shape, do you remember we sort of talked on it? We don't touch on it a whole lot in this class. But they tell you the shape of where you're going to find those electrons using kind of like quantum mechanics. But you don't need to know that. They're subshells, though. Subshells. How many max electrons can an S hold? 2. What about P's? 6. So we fill, right, zooming in here, we fill our S's completely because we have enough electrons. We have 11 electrons to go through, right? So we're going to fill the lowest energy level first. So we get through 1s2, then we go to 2s2, there's no 1p, right? Go to 2s2, fill it. Go to 2p, fill it. And then we have 1 left in our 3s1. Feel good about it? How many valence electrons does sodium have? 1 electron in the highest or valence shell. Okay, 1 electron. Another way you can know how many valence electrons you have for sodium is how? What's another way you can know how? What's that? Yeah, Lewis dots. The group number. Yeah, someone said it. The group number, yeah, it's in group 1A, so it has 1 valence electron, right? The group number for main group elements is how many valence electrons you have. Thank you, man. All right, let's keep moving along. Questions about this? Okay, let's keep moving. So, what is the abbreviated or noble gas configuration for sodium? So we wrote the full one. What's the noble gas one? Yeah, so you're going to look at the previous noble gas, right? And you're going to say, okay, for sodium on the periodic table, right? You got to kind of make a circle. Go back to the previous noble gas because we don't make it to the next noble gas, right? So we get through neon. So we have to put brackets around that. And then whatever's left over. So let me zoom out a little bit here. So this whole thing, what color do I want? Let's do green. This whole thing is the electron configuration for neon. Okay, so you're just replacing, oh, it's really small, sorry. You're just replacing the first part in green with neon because that is neon's configuration, right? It's a little bit of a shorthand way of writing it, abbreviated. And why do we like this? Well, because it shows only the valence shell, right? And then you can really easily look and say, hey, how many valence electrons do I have? Oh, well, it's just right there, 1. Sound good? Okay. All right, how many valence electrons do elements in group 2A have? How many valence electrons, highest energy, in group 2A? Yeah, 2, right? For main group, tall column elements, the number of valence electrons equals the group number, right? 1A, 2A, 3A, 4A, 5A, 6A. How many valence electrons do atoms typically want?
8.
Yeah, 8. Octet rule, right? They want 8. Typically. Why do I say typically? Is it always, always, always true? I can think of 2 elements it's not true for. Helium and hydrogen. Why are hydrogen and helium happy with only 2 electrons in their outermost shell? They only are in the 1s, right? They only make it, right? Hydrogen gets to 1s1. Helium gets to 1s2. That's a full valence shell for helium. It doesn't make it any further than that. It only has 2 electrons. It's too hard for helium to gain 7 more electrons. And this is super stable because it's like the lowest energy level, right? So this is a full valence shell with 2 electrons. That's why helium is still a noble gas, right? Super inert, doesn't want to react with anybody because it's got a full valence shell. Hydrogen wants to gain 1 more to be like helium. Exceptions, right? Other than that, though, you guys are right. 8 electrons. Everybody wants 8. Other than these 2. All right, draw the Lewis dot diagram for sodium bonding with oxygen and then give the chemical formula. So now we're up to chapter 3. So this week's stuff. Lewis dot diagram. So Na. Oh, I gotta put it on here because people are watching. All right, you guys ready? Okay, we did a lot of practice in my in-person class with this, and a little bit for hybrid as well. Towards the end of class, we did the bond with a classmate. All right, so draw the Lewis dot diagram. What do I mean by draw the Lewis dot diagram? What does it look like? Na with a dot, right? Why does Na only have 1 dot? It's got 1 valence electron. Because why? You're like, because it does. Because it's in group 1A, right? 1 valence electron. What about for oxygen? What's the dot diagram look like for that? 6 dots. Awesome. 1, 2, 3, 4. I don't know, 5, 6. You can put them anywhere. Just only pair them up if you have to, right? Okay, so I'm seeing a problem. What's the problem here?
Not enough to share to value.
Yeah, sodium, oxygen's like, I don't want just 1 electron sodium, I want 2.
Yeah.
And sodium's like, well, I only have 1, I'm sorry.
You gotta add.
Yeah, what do I do?
Add 1 more sodium.
Add another sodium. Yeah, that's allowed, right? That's legal. You can't change how many valence electrons each of these has, but you can change how many of each of them you have. Okay? So you can add another sodium ion. There's tons of them around, right? And when you do that, you've got 2 sodiums bonding with 1 oxygen. So your formula is what?
Na2O.
Na2O, right? This 2 here gives you the number of NAs that you have. And then there's no number here. Why?
Because it's full.
It's full. It's just 1. Just 1 oxygen, right? There's two sodiums, right? Of 1 oxygen. This is the lowest ratio they have to bond in for those charges to cancel. Okay? questions? All right, keep moving along here. Doing great. What is the name of the polyatomic ion? OH minus. This is just something you gotta memorize. Remember, it's on your table for your. Yeah, hydroxide. B, hydroxide. Oops. I get really fancy with these. Kind of fun. Hydroxide. OH minus. Gotta memorize it. I also have, if you need note cards still, I have a bunch of blank note cards here, so come see me after class if you need some. All right, when oxygen forms an ion, what charge does it have? Yeah, how come you know -2? It needs to gain 2 electrons. Why? Where is oxygen? 6A. It wants 2 more, right? It wants to be like 8A people. Okay? All right, 2 minus charge. Always? Yeah, always, right? I mean, I shouldn't say always, but for our purposes, always, right? What is the chemical formula for the compound that forms between magnesium and bromine? Magnesium and bromine. All right. So what charge does magnesium form when it forms an ion? 2+. How come? How'd you know that? It's in group 2A, right? It's in group 2A, so it wants to lose 2 electrons, right? Rather than gain 6. It doesn't want to gain 6. That's too much work. It's lazy. So it's going to form a 2+ charge. And you'll know that by kind of, I don't know, you write it on your periodic table at the top, 1+, 2+, jump over to the other side, 1 minus, 2 minus, 3 minus, right? Or you just kind of memorize it. All right, and then bromine. What charge does bromine form when it forms an ion? 1 minus, yeah. 1 minus. It's in group 7A. It just wants 1 electron. So it's going to take an electron. All right, what's the problem here? Are they just going to be MGBR? A? Is A right? No. No, how come? The charges are different. They don't cancel, right? That's why these want to bond together, is so that they can be neutral. That's what they really, really want. So what do I need to do? Can I change the charges? No, illegal. What can I do? Add another bromine. Yeah, that's legal, right? Now on this side, right, I've got 1 minus plus another 1 minus, which gives me what? 2 minus. And that's going to cancel with my 2+. Does that make sense? So what does my formula look like? MGBR2, right? MGBR2. Because now I've got 2 bromines bonding with 1 magnesium. It's just like H2O is 2 hydrogens and 1 oxygen, right? All right. Did I put that on there? Okay, good. Whew. C. MGBR2. Got nervous. All right. What is the correct name of AlCl3? That 3 is kind of small. AlCl3. So that's aluminum and chlorine bonding together. Ionic compound. Aluminum chloride, right? Aluminum chloride. Remember, for whenever you're naming these, it's always right for ionic compounds. It's always cation first, positive ion, plus anion, and then you give that anion the ending IDE, right? So aluminum is going to form a 3+ charge bonding with chlorine, which is going to form a 1 minus, so we get that IDE charge, or name. All right, how about NaCO3? Yeah, sodium carbonate, right? Because you memorized carbonate. Carbonate is one of the ones that you have to memorize for your polyatomics. CO3, what's the charge on CO3, on carbonate? 2 minus, yeah. CO3 2 minus. That's carbonate. So anytime you see that CO3 like that, right, you know that's a polyatomic ion. Questions about that? All right. What is the formula mass? I think this is the last one. And then we can do a Q&A after. So formula mass for calcium and chlorine. First off, what would I call that compound? Calcium chloride, right? Calcium listed first, then chlorine with an ID, chloride.
It gives me the fraction, and so
I know, yeah, because every quarter someone asks me, and they usually been trying to figure out the decimal on their own the whole quarter, and I'm like, oh, we're sold. Here's a button for that. Yeah. All right, what's the formula mass of CaCl2? Actually, I'll give you a little more time on that. Sorry. Got going fast because I'm excited.
Are we just doing the 2 decimal on the final answer, or whatever the calculator?
Just whatever the calculator spits out, especially if it's a multiple choice, right?
Yeah.
Find the closest one. But typically for these, I like 4 sig figs, but it doesn't actually, I would never mark it down at 5 or something like that. That's just the convention for these, it's usually 4 sig figs.
I see.
But just write down whatever your calculator says and you'd be in good shape for these formula masses. All right, so how do we go about solving this? Well, what I like to do, we talked about this today in one of my classes, is I like to list out what atoms I have. So, and I said it in the video too. So I like to say I have calcium, and how many calciums? Well, specifically, I don't see anything there, so just 1, right? So 1 calcium atom, and I'm gonna have to multiply that by whatever mass I see on the periodic table. And then for chlorine, I have 2, so I'm just gonna make a note of that. I have 2 times whatever mass I see on the periodic table. Okay, do you need to memorize the masses on the periodic table? No, please don't. That's a lot of work. Please don't do that. So what is the mass for calcium on the periodic table? 40.078 what? What are my units here? AMUs. AMUs. What about chlorine? 35.453. Oh my gosh, I remembered that one in my head. Okay, AMU, yeah. All right, now, remember your PEMDAS rules, right? I know it's been a while for some of us since we've done some of the order of operations, right? You got to multiply this number first. 1 times 40 point, it's just 40.078, right? But 2 times this needs to be done first, and then you can add these 2 together. Because our goal is to find the mass of that whole compound. So what'd you guys get? 111, yeah, 111 AMU. Sound good? Okay. Whenever I ask for the formula mass, right? A trick to, because sometimes I think that term can be confusing for students. What I'm looking for is the mass, right, of my formula. And when I say formula, I'm talking about like something like that, or H2O, or NaCl. Okay. All right, that's the last one I had for you guys today, but do you have any like questions? Did you bring any questions? Anything like pods, online practice, which is due tonight, right? At 11:59 p.m. Pacific time. How are we feeling about the exam?
Nervous.
How many things are questions?
I haven't written it yet, but it'll probably be about 35-ish questions. Yeah. I always write it after all of my classes so that I know how far we got. So tonight I will have a lot of fun doing that.
The periodic table that you're going to canvas, is that going to have like the names in them?
It'll have the names. It looks just like the one you have, but it doesn't have all your little notes on it.
Okay.
Okay, so charges would be a good thing to note on your little 3x5 index card, right? Remember, you get one of those. And I have a bunch of them up here, actually. So charges would be a good thing to write. Polyatomic ion names, if you're still struggling with those, might be good. I don't know. You get to decide what goes on that index card, right? But you can use the front and the back, and then I want it when you're done with your test. Does that make sense?
So is there any, like, restriction on writing something on the card?
We can write whatever we want.
Yeah, I mean, keep it PG. I don't know. What are you thinking of writing on there?
The equivalent of liters to milliliters. stuff like
Yeah.
that.
So, yep, that's fine.
Okay. My dad writes super, tiny, to get all those.
Other questions?
No, it's all good. You really appreciate this.
Yeah, good. Yeah, well, like that's all I have for you guys today, but